This is part 3 of my solution videos for the formative assessment that we did this week about solving exponential and logarithmic functions. And in this video, I'm going to focus on these problems here on the back, the logarithm problems. Let's begin up here and just imagine, well, let's just read the directions. It says rewrite each of these exponential equations as a logarithmic equation. And this one over here says rewrite each of these logarithmic equations as an exponential equation. And I actually had a student during the exam call me over and say, I forgot how to do this. I forgot how to do this. And I said, look at these 4 problems. Even more specifically, look at this problem first. You know a lot more maybe about exponents than you do about logarithms, but maybe you can look at this problem and figure out what the exponential relationship is between the 2, the 128, and the 7. And I left it at that. And I think it was a pretty good hint, actually. But notice, what I'd like for you to see here is that 2 to the power of 7 is 128. And maybe if you had scratch paper or somewhere in the margin, you could like scribble that out or think it out. So I can take this logarithm problem and just rewrite it as an exponential equation like this. And if you just take some time to multiply out your powers of 2, it's 2 times 2 is 4, times 2 is 8, another 2 is 16, and then 32, that's 5 2s, and then 64 is 6 2s, and then 128, that's 7 2s. So I just checked that this exponential equation is valid, and this informs the structure of the logarithm. And what we say is log base 2 of 128 equals 7. And so the reason I started with this problem is because it's really maybe intuitive to see the relationship between these, to rearrange these 3 numbers that are given into an exponential relationship. But a couple of good things to remember is the answer to a logarithm is the exponent, okay? That's the point of logarithms, is to get that exponent out of there and onto this side of the equation all by itself. So if I take this idea, I can go back to the first problem and use the model of problem 11 to just rewrite this. And what we say is we say log base 3, that's where we put the base, and my base is 3 right here. Log base 3 of 729 is equal to 6, the exponent. And that's it. You can just trust that I've given you a correct equation here, and if you really want to sit and raise 3 to the 6th power, you can do that even without your calculator. It might take you 20 or 30 seconds to do that. Number 10, once again, here's my base. Here's my exponent, and when I raise this base to the exponent, I get this number. So I can rearrange this as a logarithm problem by saying log base 5 of 1 over 125 is equal to -3. And finally, we can just slide over to problem 12 and do the exact same process that we did over here, where we just rewrite the logarithm as an exponential relationship. 10 to the power of -2 is equal to 0.01. 10 to the power of -2 equals 0.01. This is 1/100th, and it makes sense. This is 1 divided by 10 squared, which is 100. So I hope you can see the relationship here now between the decimal version of 1/100th and this exponential version of 1/100th. So those are all pretty easy, especially if you remember how the structure of a logarithm. And that's really what we're assessing here is, do you understand the relationship between an exponential equation and a logarithmic equation? They can be written with the same three numbers in these two different forms. Now, let's move on. Here, we're not given an equation, we're given an expression, and we're told to evaluate each expression if it's possible. And if it's not, we need to say why. Okay. So here, first of all, I know the question that I'm trying to answer with this expression is 4 to what power equals 1? And of course the answer is 0, because 4 to the 0 power equals 1. Next one, maybe a little more challenging, log base 2 of 1/16. So the question here, 2 to what power equals 1/16? And by now, I hope you recognize that when you have a fraction like this, it's 1 over some power of 2. That's 2 to the 4th, 16. You're going to end up with a negative exponent. So in this case, 2 to the power of 4 is equal to 16. So 2 to the power of negative 4 equals 1/16. And so my solution there is just negative 4. This one, the question that we're trying to answer is 2 to what power equals negative 4? And maybe immediately you recall from the problem set that this is not something that actually can be done. It's not possible. So let me try to explain a little bit of my thinking about how I know this is not possible. And by doing that, I'm going to do exactly what I did up here. I'm going to rewrite this expression as an exponential expression. Let's just imagine that this expression equals some value x, and we don't know what that value is, so we just give it a variable, or an unknown value of x. And if I rewrite this as an exponential expression, what I'm saying is 2 to the power of x equals negative 4. You'll recall from the graph of 2 to the power of x that we kind of get this curve that approaches the x-axis, but it never touches or crosses the x-axis. So if this is the graph of y equals 2 to the power of x, you can see from the graph that 2 to the power of x will never cross the x-axis and be negative. So there's no way that y will ever be negative. In other words, there's no value of x that's going to give us a negative value for when we raise 2 to that power. So not possible, or undefined if you like. Let's just write undefined. Undefined. There is no power of 2 that gives a negative result. Okay. And finally, this last one, and this one is a little bit tricky, but once again, we have this radical, and I know that I can deal with, in this case, it's just a square root. It's not a third root or a fourth root or anything like that. So if the square root of 27, that's the same as the problem on the other side. This is the same as 27 to the 1/2 power. So let me rewrite this as 27 to the 1/2 power. And remember the question that we're asking. We're saying 3 to what power equals 27 to the 1/2 power? Well, let me rewrite this as a power of 3 in order to just get my bases all lined up. This is 3 to the 3rd power, and I'm raising that to the 1/2. Let me get my parentheses straight here. So now my 27 is written in terms of a base of 3. And so, again, I can simplify that using the power rule. Log base 3 of 3 to the 3/2 power. What does that equal? Well, think about it. 3 to what power equals 3 to the power of 3/2? The answer is just 3/2. And That's our solution.